Lesson 8.5, problem solving with trigonometry. So right off the bat, I'm going to be honest. This is going to be an abbreviated video. We're not going through everything because some of the classes don't cover everything needed to solve all these problems. So just keep that in mind. So you are basically taking all the trig you've learned, sine, cosine, tangent, for all those regular classes, and some of the pre-AP or advanced classes might have learned law of sines, law of cosines as well. So this first problem, everyone should be able to solve. It says a search and rescue team is having a nighttime practice drill. 2 members of the team are in a helicopter that is hovering at 2,000 feet. The team first tries to locate an object A at A. At what angle of the horizontal line, even with the helicopter, should they position the spotlight so it shines on object A? So keep that in mind. It's looking for this angle right here. This is a right triangle. We have the base of the triangle and the height of the triangle, that 2,000, to point A, but we're looking for this angle that's not even part of the triangle. So you might want to think that out. Because this is a right triangle, from here to A is what we're looking for. We'll just call it X. But right here, which is part of our triangle, we can solve for this, whatever we can solve, using inverse trig. We can use the, we can use the side lengths, these two measurements, the 3,200 and the 2,000, to find this angle. I'm going to just say A for angle. Once you have that angle, remember this is a right triangle or a right angle up here. So subtract 90 minus A, you will get that main angle measure. And we'll learn more about that in just a second. But next, they shine the spotlight on object B, and you're going to solve something similar to what we just did. Example 1 is the critical stuff everyone has to know. Whatever geometry class you're in, you need to know this. This is angles of elevation and angle of depression. So this is what I want you to imagine. If I had my eyesight right here, my line of sight comes directly out parallel to the ground, and it's perpendicular to my body, so it's straight out. And if I were to look up from my line of sight, that's an angle of elevation because I'm looking upward. But if I were to look downward, that's an angle of depression going downward. So if you look at this problem, it says identify angle 2 as an angle of elevation or an angle of depression. So you need to figure out where the person is. Here's the person, angle 2. Are they looking upward or downward? If I was talking about person up here, angle 1, would be different because this person is actually looking downward, where at angle 2, this person's looking upward. So angle 2 is definitely an angle of elevation, but angle 1 would be depression. How about number 3? Try to figure that out. Try it says, how do these angles compare with each other? So angle 1 and angle 2. There are actually several different answers. You can say one's an angle of depression, one's an angle of elevation. But think about this. The line of sight of one person and the line of sight of the other person, they're creating parallel lines. See those parallel lines? Even with down here, this person, all these are parallel. There is a name for angle 1 and 2. If the lines are parallel, which they are, these should be alternate interior angles. This is example 2. It says, for a reverse bungee ride, Reagan stands halfway between 2 vertical posts. 2 bungee cords extend from the top of the post to Reagan's waist. That is about 1 meter. Notice the 1 meter right over here above the ground. How tall are the vertical posts? So you are looking for this X. So you're going to use your trig skills, and let's label everything. I've got my angle. I've got this X going all the way down, which happens to be the opposite side of my angle. And then I have this distance right here, which it kind of is hard to tell, but they said this person is standing right way in the halfway point, so that would make this 4 meters on this side. So I have the adjacent side, I have the opposite side is what I'm looking for, and I have the angle. So using your trig skills, which one of these has opposite and adjacent? That's the trig formula you're going to need to use. So tangent 70 equals opposite, which is x, over adjacent, which is 4, cross multiply, grab those calculators, plug that in, and see what you get. When I got this, I worked it out, and I got x equals 10.9899, probably 11-ish. So it says, let's see, how tall is the vertical post? It doesn't tell us to round, so I'm just going to leave it in there for now. But I do need to take into account this 1 meter. So that pole is x, 10.9899, but how tall is the whole thing? We have to include that 1 meter. So I'm going to add 1. So roughly 11.9899, we're going to say 12. Approximately 12 meters tall. Nadim sees the tour bus from the top of the tower. So up here, Nadim looking downward, angle of depression, to the nearest foot. How far is the bus? How far is the bus to the tower? So when you ride a bus, you're not going to float up here in the air. This is the length we need. That's the distance that the bus is from the tower. Remember, this line of sight, and the actual road, those are parallel lines. So if this is 23 degrees, this would also be 23 degrees. The angle across is the opposite. We're looking for the adjacent side. Oh, looks like we're using tangent again. Tangent of 23 equals opposite over adjacent, cross multiply, and see what you get for x. I got 424.05, yada, yada, and it says round to the nearest foot. So I'm going to say 424 feet. That's how far the bus has to go. Starting with example 3, that's where I'm going to stop, is right here. So if you need instructions on that, you're going to have to talk to your teacher directly. But this uses more of the advanced trig, laws of sines, laws of cosines. If you're in pre-AP geometry, you will need this most likely, but ask your teacher just to make sure. The one other thing you might need is to find the area using trig. And so I am actually just going to show it to you at the concept summary. Not all teachers will require this to find the area using trig, but these formulas can help you find the area of a triangle using trig, or you can just use trig to find that height and then find the area 1/2 base times height. So it's up to you. Some teachers require you to use these formulas, and other teachers will just have you use trig to find all the missing parts of the triangle, or triangles, I should say, because there's 2, and then just do 1/2 base times height. So talk to your teacher about that. The biggest thing that we learned in this lesson for all geometry students is you need to know the angle of elevation, that's looking up or going upward, angle of depression going downward, and then using trig to find the missing pieces of an application problem. I hope that helps.